So this is a little bit of a preview of what we'll be doing in this section. So we're going to go over angles. You should have been exposed to some angles in middle school. So we're going to go over how to use a protractor to measure those. Let's look at AOB. So what I want to do is I'm going to highlight AOB. I'm going to note that that's the one that I'm looking at here, AOB. With my protractor, if I'm measuring an acute or an obtuse or a right angle, typically the easiest way to read an angle, if it's possible, is when one of the sides is on the zero, right? So this is an acute angle. Do you remember what acute means? It's less than 90, right? So it's less than 90, so I don't have to read the top number. It's in between 40 and 30, so it must be 35 degrees. We're going to hop on over to BOC. So let me go ahead and erase this here. So, BOC. I'll tell you how I do these kinds of problems. So BOC, this is a little bit more challenging because I don't have a side that is on the zero, like the way OA was. I'm looking at this one in red. So what I'm going to be doing to find this angle here is it's really just a subtraction problem. And this is what I think about when I am finding BOC, something that isn't very easy to read because I don't have one side on that flat line there. So I think to myself, okay, I'm going to start with the top one, which is the larger one, COA. So I'm going to look at COA. Which is that angle right there. If I look at angle COA, how much does COA measure? 65, right. So the measure, and this is how we denote it, the measure of angle COA is 65 degrees. Well, I'm not looking for COA, I'm looking for COB. Well, I looked at COA, which contains COB, and then I'm going to look at BOA. What's that measure? 35, right. The measure of angle BOA is 35 degrees. Well, when I take COA, which is this large angle here, and I subtract BOA, what am I left with? I'm left with this angle here. Does that make sense? So when I find that difference, the measure of angle COA minus the measure of angle BOA, I get what's left over, which is COB, which is what I'm trying to find, which is 30 degrees. That's actually something that we're going to talk about later on called the angle addition postulate, what we did right there. The angle addition postulate allows us to find those angles that aren't fully aligned on the bottom. So for C, we get 30 degrees. Does that make sense what I did? Yes? Okay. So what did you get for E? Anyone? What did you get for letter E? Yes. 80 degrees, right. And you can apply that same logic to COE. If I look at COE, again, that's an angle that is not the easiest to read, but it's a subtraction problem again. So for E, you can look at that as a subtraction problem. I looked at it as the measure of angle EOA minus the measure of angle COE, and what's left over, or sorry, COA. So I took the measure of angle EOA, and I subtracted the measure of angle COA, and I got the measure of angle COE. So just to make that a little bit more clear, I'm going to highlight it in a few different colors. So let's highlight EOA. When I take that large angle in green and I subtract it from COA, which is that measure in red, then I get COE. Questions? No? Okay. What'd you get for G? Any thoughts? 75. 75 degrees. Okay. Questions on that? To make it even simpler for C and G and E, all I did was I took the last one minus the first one using that straight angle. So this was COA minus BOA. This was EOA minus COA. This could be DOA minus BOA, and you'll get those answers. All right, any questions? The second minus the first, using the straight line. So COA minus BOA for C. Okay, so these are the answers. I don't know how many you were able to get through. And they also classified them acute or obtuse. Remember, what's an obtuse angle? Yeah, greater than 90. So today we're looking at 1.5. So as promised, you are looking at measuring and classifying angles today. So the first thing that we want to look at is how we can name an angle. And I will say one way is preferred over others most of the time. So it says an angle is a set of points consisting of two different rays. So here we have ray AC, and here we have ray AB. When they meet at a common endpoint, that common endpoint is A, they form what is known as an angle. And that endpoint is called a vertex. So I will often point out the vertex in a diagram, and that will be used to help solve different types of problems. So be familiar that common endpoint that forms the angle is known as the vertex. The rays form the sides of the angle, of course. So it says you can name an angle in several ways. You want to be very cautious of using just one letter to name an angle. The only time that's acceptable is if you don't have a bunch of angles connected. So for example, if I gave you a picture like this and I had M in the middle, you couldn't say that, oh, I'm looking at angle M, because I don't know if you're looking at this angle, I don't know if you're looking at this angle, or I don't know if you're looking at this angle or this angle. So you want to avoid just using one letter unless it's very clear that the angles are separated and it's very easy to see. Now, the second part is the most preferred. Use a point on each ray and the vertex, such as angle BAC or angle CAB. So notice that that vertex is always in the middle of your angle, always. So when you name an angle using the second bullet point, which is most often what we'll be doing, you want to have the vertex in the middle of the name. The last way that you'll often see angles labeled is by a number. So in your homework, for example, they like to do that. They like to put 1 or 2 to denote the same angle. So 3 different ways. You can name it using the single vertex, which you want to be careful of. You can name it using 3 points with the vertex in the middle and 2 other points that are on the rays that form the angle. Or you can name it using a single number. Do you have questions on how to name an angle? All right. It says the region that contains all the points between the sides of the angle is the interior of the angle, so just the inside shaded region. The region that contains all the points outside of the angle is called the exterior, so you have the exterior of the angle here. All right. Thoughts, questions, concerns? Anyone still writing? Okay. So in this example, you can see what I was talking about. You don't want to just call that angle M. Why? Because that can be very confusing. If I'm looking at this here, I don't know what you're referring to when you just label it angle M. It could be this angle, it could be this angle, it could be this angle. I don't know. So you can name it a couple different ways. It says a lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name the 3 angles shown in the diagram. So they have JMK, and that can be named as KMJ. They have KML, which is the same thing as angle LMK. They have angle JML, which is also angle LMJ. The only difference is they're switching around those endpoints, but they always keep that vertex in the middle. And then when you're naming those angles, of course, include an angle symbol. Questions on that? All right. Let's move on. So we talked about this already. You don't have to write the protractor postulate down completely. A protractor postulate is basically saying that you can use a protractor to help measure your angles. And we'll go into more detail with that and the absolute value here in a second. So a protractor helps you approximate the measure of an angle. The measure is usually given in degrees, again, appropriate units. The common error, most protractors have an inner and outer scale. When measuring, make sure you are using the correct scale. So, of course, most often with our obtuse angles, we're going to be using the outer scale or the inner scale. With our acute angles, we're going to be using the inner scale. So it says consider line OB and a point A on one side of OB. The rays of the form OA can be matched 1-to-1 with the real numbers from 180. So they just said that you can make this angle right there that you see. The measure of angle OAB, which can be written as the measure of angle OAB, M in front. So that's important. Anytime you say the measure of an angle, you just want to put an M in front. That means measure. Measure of AOB. Of angle AOB. The measure of angle AOB is equal to the absolute value of the difference between the real numbers matched with OA and OB on a protractor. So all that means is here and here, you look at those numbers. This is 140, this is 0 degrees, so you subtract them. 140 minus 0, and you get 140. That's what I was doing in the beginning with that bell work. I was finding the differences and using that protractor postulate combined with the angle addition postulate, and I got the measure of the angles, which we'll see here in a minute. Does all this make sense? And then, of course, they're going to talk about the types of angles that we've already discussed earlier, which are our acute angles, our right angles, our obtuse, and straight angle. So the two ones that you want to make sure you pay particular attention to are the right angle and straight angle. The right angle, we're going to always denote, or most of the time denote our right angle with a little box. That's an implied 90 degrees. Acute angle, remember, it measures greater than 0 and less than 90. I just think of an acute little angle, something small, less than 90 degrees, but greater than 0. Obtuse, greater than 90 and less than 180. I think of obtuse, obese, larger than 90. And then you have a straight angle. For some reason, the concept of a straight angle can go over people's heads. If it's a straight angle, it measures 180. Okay? I think of a straight angle, a straight line, and also a semicircle. You can make a semicircle here. How much does a semicircle measure? Do you remember? How much does a full circle measure in degrees? So how much is half of that? 180. So I just draw a semicircle and I think to myself, okay, semicircle is 180, so a straight angle is 180. Does that make sense? Questions on that? Anyone still writing? Okay. On record. I'm looking at the measure of angle LHK. LHK, that's an acute angle, meaning it's going to measure less than 90. To go back to the bell work, all I do is I say, okay, I'm going to look at L and I'm going to look at K. So LHJ is 90 degrees. And then K. KHJ is 55 degrees. You see what I'm doing there? I'm just using this straight side with L and K and finding the difference between those two angles, and that'll give me this angle. Yes? So when I do that, what do I get? 35? So I get 35 degrees. Thank you. Okay, the other thing, it just says we're looking at measures that are equal, and angles, two angles that have the same or equal measures are congruent to each other. So if, let's say the measure of angle A is 45 degrees, and the measure of angle D is 45 degrees, then the measure of angle A is going to be equal to the measure of angle D, and therefore angle A, without the M, is going to be congruent to angle D, without the M. Does that make sense? They're saying the same thing. The top one's just saying that the measures are both 45, and this is saying that the angles themselves, which equal 45 degrees, are congruent to each other, the same size and shape. Questions? No questions? This all makes sense? All right. We're taking a look at congruent angles. One thing I want you to be aware of is how we denote angles of different measurements. We use arcs, okay? So for example, I want to show visually that angle G and angle B, and I can call them angle G and angle B because they're not all connected, right? It's okay that I just use that one capital letter. If I want to show that angle G and angle B are congruent, I'm going to use a single arc, or a double, or a triple, but in this case I use a single arc. Now, I don't want to let you be confused as the reader and say that angle G is congruent to angle F. They're different measurements. So I use a double arc, not so as not to confuse you. So just a double arc there and a double arc there. Does that make sense? So that tells me that if they have the same arcs, then they're congruent. So angle G and angle B are congruent. So the measure of angle G is equal to the measure of angle B, which means that angle G is congruent to angle B. And likewise, angle F is congruent to angle D. They have the same measurement. So oftentimes you'll see those arcs. You'll see a single, double, and a triple. It says the measure of angle ADC is 140. So this is 140, ADC. What is the measure of angle EFG? 140 also, right? Because they're congruent. So for part B, we have the measure of angle EFG is 140 degrees because it's congruent to the angle ADC. So they're both 140. Does that make sense? Questions? Okay, here's the hard stuff. So hopefully none of that was too difficult. Looking at the angle addition postulate now. This is a key one that you'll see on your test. Your first test, you'll see a couple problems with the angle addition postulate. You'll see it on your midterm. You'll see it on your final. And this is one that can give students some trouble. So this is similar to the segment addition postulate, where if you add all the parts, you get the whole, right? So we worked with the segment addition postulate. The angle addition postulate is the same, but for angles. All this says is that the pieces of the angle form the whole angle. So if I want to look at, if I take this angle here, and I add it to this angle here, then I get the big angle, angle RST. Does that make sense? If I had, let's say if I had the measure of angle RST, the big angle, and I subtracted the measure of angle PST, what would I get? Oops, sorry, let me write that down for you. If I took the angle RST, the big angle, and I subtracted angle PST, one of the smaller angles, what would be my resultant angle? RSP. So on those problems, they'll be replaced with variables and things, and then you'll have to apply that angle addition postulate. Questions? A couple more practice slides and we're done. So this says finding angle measures. We have example 4 to look at. It says given that the measure of angle LKN is 145. So I always mark my diagrams. LKN is this giant angle, and that's 145. Find LKN. So I'm going to find this angle here on the inside, and MKN. So that's this angle here. So the two smaller parts make the larger one, right? So one of the smaller angles is 2x plus 10. The other small angle is 4x minus 3. And they make the larger angle, which is given to me as 145. So now I've got a two-part problem. I have to solve for x, and then I have to plug it in back into each of those individual angles to find the individual measurements. Does that make sense? So of course, I'm just going to do some simple algebra here. I'm going to combine my like terms. So I have 6x plus 7 equals 145. Subtract 7, subtract 7. 6x equals 138. Divide by 6. Divide by 6. X equals 23. That's not your answer. That's just a key to your answer. Now you have to plug it back in. So you take this value and you plug it back in. So let's take a look at the measure of LKM first. Well, that's going to be 2 times 23 plus 10, which is equal to 56. Does that make sense? And then you look at the other one, the measure of angle MKN. And that's going to be equal to 4 times 23 minus 3. And we get 89. Or once you find one of them, just subtract it from 145 and you get the other one. Does that make sense? Do you have any questions? Am I moving too fast, moving too slow? Is this okay? Are we good? Are we alive? Okay. So, did you get 13 for x, if you did this one? And did you get 125 and 55? Okay, then you're good. Now, one special word that you need to know, or words that you need to know, is called linear pair. Two angles that add together to be 180 form a linear pair. That's a good word to know, linear pair. Now, same thing is true for two angles that measure 90. They're not called a linear pair. They're called complements with an E, not an I. So I got x is 29 on the second one. I added them up, set it equal to 90, combined my like terms, solved for x, got 29, plugged it back in, got the measure of angle EFH to be 60 and the measure of angle HFG to be 30. That makes sense. They're called complements. Questions? Okay, notes will be short tomorrow. We're going to do constructions. So bring your compass, and we are done for today. Thank you so much for sticking with me. Let me know if you need help or if you have a concern about your grade.